Hello, everyone. Welcome back to another programming session. I'm Sajjad, and I'm hoping to work on the Rumi programming language in this session. So I took yesterday off because I was getting a little bit tired of streaming every day. But we're back at it today, and I made some progress off camera. Just fixing some bugs here and there, and I'm really glad at where we are at the moment. So let me show you the latest thing we've done. Just to prove that we have a working compiler, we wrote a very small program that is going to here. We wrote a small program that basically defines a few macros for us, a CLI parser macro, along with a string reader macro. And if I clean it up a bit, you can see the way we define a struct here in this program. After importing our macros, we define a struct here, and this is the syntax of the macro. You don't have to write like this in Rumi. And the macro says we want to start a CLI program using this struct, and I have an incremental value in dash v, and I have a optional flag in dash r. And what this does is it generates basically generates a parse method for that struct here that we can just call on any member of the struct, and then we have ourselves a very nicely written program. So you can see we print the value of v and we look at the value of r, and this is done automatically on the macro side. The other macro that we have is str from file, and this macro reads the content of this file and replaces it here. So you don't have to, it basically hard codes the value of that file in your program during compile time, right? This is very useful, for example, if you're working with OpenGL and you want to include your shader codes inside your program, right? So let me show you. So if you run the compiler, there is no messages, and if I compile it and run it, let's just compile it. If I compile it, oh, we are in the wrong directory. That's why. Okay. So this is a compile time. The compiler is doing some things for us, and now I can actually compile it again and run it, and you can see. So value of v is 0 and r was not set, that is expected. And I can do this. Value of v would be 1. I can do this. Value of r would be set. And so in very few lines, we go from a struct to a struct that can parse your arguments. And so the goal of Rumi is to allow developers, library developers, to develop these small, these basic macros that you can just import and use in your program. And that's what makes Rumi very powerful. Now, in today's session, I'm hoping to add a few different things to Rumi. First of all, in the current system, we don't really have an error handling, error reporting. When the program fails to parse, it just prints a line of code saying I couldn't parse there. There's no information about what line the error is, or what exactly happened, what went wrong, what were you expecting, what did you get. There's no information about that. And I want to handle that in today's session. I'm going to take a bite of this. All right. So the first thing that we want to do, we have this cc header file, This is the basic of everything that we have. And I want to add another class here, and this is going to be the debug class, or actually debug info, just to be consistent with other things. Now, debug info is supposedly contains the information about our program, about different parts of our program. So at the very least, we need to have a line number inside of it, along with a character column number. So that's what we're going to do. We're going to define a debug info.header, pragma once. We have class debug info, and here's what we have. We have a public constructor, so we can construct ourselves from a token. We can construct ourselves from a what's it called, a parse result. And from an AST. That's the ultimate goal, right? But I'm not going to write all of those at the moment. I'm just going to write the token first. We can work on the others as we go along. And we also have a print statement. So you have a cd string to string that is going to return your value. We can either do it like that, or we can take a look at the parser. Not there, parser.header. Or we can define something similar to this. So where did it go? Is it in token? Yes. We can also define something similar to this one. Oh, what did I do? Right. This is a string. No, this is a string, and this is a debug info, and we include string for the symbols. There you go. There you have it. Now, this is a C++ file with as such. It doesn't know what the token is. Doesn't matter. We can tell you that the token is a class. You don't need to know what's inside of it. Oh, come on. Right. So that's what we have. Now, debug info should store some things for itself. For example, it should have I guess that's it at the moment, right? Yeah. Let's just keep it like that for now. Now, what we want to do in a token, we want to add a method that constructs a debug info from our token. Now, the way to do it would be to say you have a method that returns a debug info, a pointer to a debug info, mind you, gets pg, and yeah. You don't need to know what the debug info is at this point. I'm just going to say it's a class. That's all you need to know, right? Yeah. Yeah. So that's all you need to know for now. Now, we are going to define the get debug method inside parser. That's C++. So I'm going to say debug info star token get dbg, like so, and you can include it's in the header, isn't it? Debug like info.h, like so. Debug info. There you go. Now, what do you want to do? We want to return a new debug info containing this. That's all we're going to do. Now, given that our token has a starting position, an end position, and a source block, I think it's only fair that we capture those values here. So I'm going to say int starting position, int ending position, source star s, and cc star cc. We might need it for anything else down the line, but for now, let's just define them like this. Now, what we want to do, we want to create a new file called debug.c++ that includes debug info.header and create the constructor for us. So we have to define three methods: the operator, the toString, and the debug info. They're easy to do, right? Just to make this easier, I'm going to define this as a virtual method. You might need to override that later. Okay, so debug info, token start. So how do we want to proceed? I guess we need to have the token information here. Parser, I think that's where it is, right? Probably. So our starting position would be this. This is starting position, end position would be that. The source code would be that, and the CC would be that. There's nothing to it really. What's your problem? Where's this file? It's in parser. So that's our debug info. I don't like it that it is still showing me an error. Yeah, the file is there certainly. What's wrong? I don't know. We'll figure it out once we compile. Right. So you have that. We potentially want to include a method that handles different things for us, but let's not get ahead of ourselves. We have the OStream operator. We want to return OStream based on a debug info. Now the way to do that would be to say like so, this the toString. That's all we need to do, right? Yeah. So how does the toString method work? Well, we want to return a string, right? We want to return a very basic string describing where we are, and it could potentially look something like this. So we can have a std string builder std, and we can return std dot what do I have to include string builder or something? This is a string buffer. I don't know what it is actually, but I know I have used it in the source. So SSTR, what's SSTR? The string. Okay. I guess that's as a string. Right. So what we want to say, we want to print the file name first, or rather, you want to print this character first, and then we want to print the file name which is available inside the source. Seriously, what's the problem there? I'm going nuts. Okay, so you have a name, and you are going to add a column, and you're going to have the line number. So let's resolve in the line number somehow. We don't need to do that. We can just iterate over it, right? Right. So we can just count this. And the way to do that would be line number would be std count. So you want to count the number of things inside the source dot string. I guess we have to add a begin there. And source dot string dot begin plus starting position. And we want to look for new line characters. Right. Add the algorithm. That should do it. Seriously, what's the problem there? Do we have a problem in this file? I don't know what the problem is, and it's driving me crazy. Right, but that should potentially be it, right? Let's generate a CMake, and let's compile this. So we aren't doing anything. I just want to see what the compile error is actually before going forward. Because if there's anything serious going on, we should address it now. I think it should be fine though. Okay. That does make sense, right? What about now? Seems okay, right? So that was the problem, and if we fixed it, it wasn't anything serious. Undefined reference to debugging tool. Okay, that is because your CMake doesn't include my rule in here. Right. Undefined reference to debugging flow token. Oh god damn it. I don't know why this is happening. But hmm, so this is in base, and base is being linked with parser and AST, right? So how can we make sure how can we tell that it's okay? Can I remove everything and then rebuild again? Regenerate everything and recompile everything. I don't know what's going on, but this should ideally fix it, right? Although maybe it could be that parser is trying to make a static build and it doesn't have any reference point to that, so that could be the problem too. But I don't know. We'll see. If that's a problem, I'm just going to move the debug info inside the parser, and that should be it, right? The implementation, that is. Right. So how's everyone doing? Is everyone all right? Anything interesting going on? Yeah. The parser, leap parser A does require that. So what we are going to do, we are going to move that. We are going to move the implementation inside the parser, but only that. So kill that. Right. Now this should do it, and you need to source from your header, like so. This should do it. We have to remove it from here. Regenerate, recompile. Yeah, that'll compile. Okay. So with that done, we can go to the source implementation, and here it do print some errors, right? So previously, when we couldn't parse something, we would do something stupid like that. But now I wanted to say debug none couldn't parse, and then we should return a debug info instead of doing it directly. So um, hmm. Well, we don't have a debug info there. You see, okay, so it's too early for that. We can go back to that in a second. Now, the other thing, we can have a constructor from a parse result. And the way to do that, again, you have your parse result. Assume you have a parse result class. Right. The way to do that would be very similar. Actually, I'm going to do this. Let's move all of that up. And here, just called from token. And now, if there is a P, we will call from token the token. And if there is not, from failure, P failure. Now this is going to complain that I don't have a failure, but we are going to define that. So in token.h, we have a parse result, and you should also have a failure. So if you do have a token, your failure would be 0. Otherwise, right. So in this scenario, you don't have a token, but you do have a failure, like so. Now, how do we define a failure? We write one. Now, what does failure have? Failure has a position, has a source code, and a CC. Right? It doesn't have a starting position like the other one, but that's fine. Okay, so in this case, the from failure method this is how it's going to do. So we don't have an end position. We do have a starting position though. So let's do that. The starting position would be failure.position. Our source would be t.source. Our cc would be t.cc. Actually, we don't even need an end position at all. We only need the position, right? So let's go there, that to that. And I'm going to do this one from failure star f, and let's have a void resolve line number that we can call whenever we see fit. Void resolve line number. I'm just going to do this so we don't repeat ourselves, right? That's the idea. How do we resolve the line number? We do that, and here we call resolve line number. Here we also call resolve line number. Okay, what's your problem? Doesn't know failure, that's fine. You have a class named failure. You don't need to know what's inside of it. The implementation knows, and that's enough. Right. This is position. This is failure. That thing and failure that. And then you just call a resolve line number. Now, is that enough? I think so. I think so. Let's see. Now, what we want to do, there is a possibility that you don't have a failure or a token. And in such a scenario, you have to set unknown equal true, and you'll have a boolean unknown which is false by default. And let me say these are processed and these are, yeah, they're okay. Now, when you're returning this, if unknown is true, you aren't going to do anything. You're just going to return and say unknown location. And that is necessary because there is potentially cases where we don't have a failure or a token, especially when we are developing, right? So we're going to keep it like that, and instead, ask the user to give us the code so that we can implement the problem properly. Now, failure. We can also add this since we have the thing, right? Right. I think that's fine. Okay. Now, inside the source here again. So here you see we are printing the token directly. What I want to say, print the token dot what's T actually? T is a parse result. So this the token dot get debug. We want to print that. That's on medium, so we have to say we are on medium. You can do that when you're running a test. Okay. Return 0 is ambiguous. Right. So it doesn't know if the 0 here is actually a parse result or a failure. And we are going to say this is a how should we say it? We should say something along the lines of this is a, we can say, it doesn't matter really. Compilation process, compilation, okay. Hit, recompile. Now we probably have the same error in multiple places because I'm doing the same thing in multiple places. We can solve them one by one. So token.h here, that's the ambiguity. It doesn't know if it's a failure or a token. And to do that, we can actually say something along the lines of, yeah, we should just return an empty parse result, right? So there, new parse result without anything inside of it. And I'm going to actually copy this line and go wherever we have the problem. So we have it here. We are returning 0, right? So I'm just going to paste that there and do that. Right. Next, we have a problem on line 88 of function parser. So you don't delete 0, you return new parse results, which is empty. And that's going to take care of it. Right. The next error would be here. Don't return 0, return a new parse result, which is empty. Next, we have ID parser, don't return 0, return new parse result that is empty, and do the same thing here. And here. Oh, I shouldn't put new everywhere. God damn it. Okay. We can solve that. That's not a big problem. No new there. Okay. Delete the new. Delete the new. Delete the new. Okay. Let's see. Do we have any other errors? Interface parser, sure. Let's see. Interface parser, line 49. Return parse result empty. Okay. Where else do we have problems? We have it in keyboard parser. Keyboard parser, line 27. Yeah. So this should be return parse results empty and parse result empty. Okay. Where else? That's everything. Okay. Compile. Oh, we have some more. Of course we do. Because I didn't put -k flag in the compilation process, so I mean that's never going to happen, so let's just delete that. Next we have it here. Ooh, we have a lot of those. Okay. Any other return 0? No. That's a string parser for us. Let's see. We have primitive type parser. Return parse result. Okay. There you have it. Number parser. Return a empty parse result, like so. Huh? Okay, that was the last of them. Let's compile. Symbol parser, line 7. Okay, that's that. What else? Symbol parser, I fixed those. Primitive type parser, line 26. Okay. Return an empty parse result. File. Parser C++. There we have an empty parse result. Let's copy that for every one of these. But I guess this is the last one that we are going to get an error because this is alphabetically the last one. So that's a good news. Right. File again. 285. Okay. Guess we missed one. Okay, so that's that's the last of them. We should get a very good result now. Now compiler. Okay, that finished. Let's see. Let's go to tests. Is test one good? Sure. So one YouTube prints. You know what? Let's export Rumi. Right. I want you to do that with two dash v flags. And of course, you got the wrong results. Of course. Now, why did that happen? That happened because in the debug info.h, we also have to define something like this. Do that and recompile. Okay, now it should print printing instead of printing the pointers. Right, let's see. Oh, it's still printing the pointers. Okay, so that wasn't a good idea. Let's go back. Let's go back. Okay, you undo that and you undo this. I think it would be enough if I add a star here so that it dereferences it. Right? Ooh, you know why? I have to include the debug info here so that it knows it can convert it to a pretty string. Right? Yeah. Okay. Do it again. Right, you can see it says I parsed the first one at test.drum0, the second one at test.drum1, and so that's good. Now, actually, this was a test only, so let's go back to what it was. But we want to go to parser.drum and where we parser.c++, and where we define the operation here. So instead of printing that, we want to say the token has a get debug method that actually has a pretty good pretty printing. So print that and do something like this. Okay. Now we don't need this include anymore, so let's remove that and recompile. Let's see what happens now. Okay, I think we are going to get our token along with a good line number next to it. Right, so you see test.drum line 0, that's a bug, we have to fix that, is this, and line 1 is this, and line 3 is this. And verify that by looking at the code. Actually, yeah. So let's verify that by looking at the code. Line 0 is that, 1 is that, and 3 is that. So let's add a +1 to the line resolve method, and that's going to fix the 0 counting. So just add a 1 there. Yeah. Okay. So that's our debug info. We have a very good debug info at the moment. Now, what we need to do, we need to go into our AST method, AST function, and so we need to have a debug info inside all of our AST instances. And I'm going to do this. Oh God, it's going to be a pointer. Let's add it up as a pointer. And to make things easier, I'm going to do a set uh, set dbg that is going to capture a debug info, and this is going to be defined as, very basically, you're just going to set your value to that, right? Nothing fancy is going on. So dbg should be, yes, let's call it dbg. Okay, right. Now, ideally, we can also do this and return this at the end to make using it easier. What do I mean by that? Well, look at this function, for example. Look at parse, I don't know, address parser. We are returning the ASD, and we can just say that set dbg to this, or rather, this is an ASD. Right, so to actually get dbg, like so. This returns a debug pointer that is going to capture. What's your problem? Can you tell me what the problem is? Wait, what? What's the problem here? Seriously. Expected semicolon. Okay, you know what? We don't have to do it there. Where we have to do it would be um where should we call this? So I want to do it once. I don't want to do it everywhere, right? Go back to this being a void. I think that's a easier thing to handle, right? And you want to call it once. So where are we defining token.h? Is it in parser? Token should be here, I guess, because yeah. Now I want to do something like, I want to add a wrapper around the toASD function, but this is a virtual, so I can't do that exactly. So what I can do, I can make the toASD a private function, right? Like so. And instead provide a not virtual, a ASD star gets ASD function that I am going to define as this. So Ants would be this.toASD, and then I'm going to say ants.set. Look, if there's an ants, that's a debug based on my debug, then return ants. Okay? Now, if I compile this, I should hopefully get a few compile errors to help me replace any instances of toASD with a getASD. I hope so, at least. Yeah. Right. That is good. So we can just go through the errors. um, and replace to ASD with get ASD. Okay. Oh no, this should be twist. Okay, the definition should be the same. Only the output should be get ASD instead of UA. Right. Okay. That's fine. Assign parser. We solved that. What's next? Binary operator parser. So we have a bunch of them here. Let's just replace them one by one. You know what? We probably have the same error for all of the parsers, so let's just go through them one by one here. So we have the assign parser that is done. That should be get ASD. Boolean value parser. I don't think that has anything. There you go. Define parser. Like so. Directive parser. Like so. Dynamic parser. You know, just a replacement, right? So that's fine. This is okay. This is sure. Okay. Two. Right. Surprisingly, not all of them have a get ASD, which is, really bizarre in some cases. Um, yeah, you see, for example, this one doesn't have a TUASD. I don't even know how that's possible. I guess those are the baseline of our language, right? They don't rely on any other token to be parsed, so they don't have a TUASD call. Right. There, and that's fine. Okay. Sure. Almost done. Hopefully I'm not missing anything, right? That would be bad. Well, it wouldn't be bad because the compiler will catch them, but still. Right, and there. There. Right, that's fine. That's fine. Okay. So let's compile this and see if we get any errors. We do. Class ASC has no member ID. Right. This isn't a basic thing, it's a function. So further to that, and this isn't a AST, it's a method. Right? No, that's a function 6. Oops. Okay. That should be fine. Yeah. Now we have an error in source. Okay. Yeah, you should be get AST. Right. So at this point, all of our ASTs have a debug information attached to them. Now, what we can do wherever we are producing an exit statement for whatever reason, we should tell the user what went wrong, right? We shouldn't just exit. And that's precisely what we've been doing. So I'm going to search for the word exit, and wherever we are calling exit, I'm just going to replace that with a graceful exit. Now, so first of all, let's define this graceful exit. I think since this is a very basic thing, we should define it in here. So I'm going to define a function called graceful exit, and you are going to get a debug info. Now, how is this defined? Well, you go here. So void graceful exit is going to print the error, print the debug info, potentially with a std string lowercase error. That could be empty, right? So you are going to um, say std the error at, remember that debug info actually has something like that, so we can dereference it and just put it there, and then say std end line, and then exit with 1. Okay. Now we have to include the debug info .h, debug info .h, so that we get both that thing, the conversion. Right. That should be fine. Now, let's try it out for something very basic. I'm going to do that for variables. Now, variable. Do you see variable here? Variable value, right? The variable value. Yeah. You see, we are printing couldn't find variable, and then we're just exiting. So I don't want to do that. I want to say graceful exit on my debug information and say couldn't find variable ID. Right? Let's compile that. We only change it in one place. Right? I'm going to test this place to see if it works, and then we're just going to change everything around that. So while that goes on, let me open up a test file. So here I'm going to say A is undef. So undef is not defined, and this should produce an error for us. But let's see. Let's wait for the compiler to finish compiling, and then we can try that. Okay. Almost done. Right. I don't like this playlist of the music. Let's change that. Let's try this one. Do let me know if the music is bothering you or if it's too loud or any other problem. I'd be happy to change it. Right. Undefined reference to graceful exit. Wow. What? That's weird. That is very weird. Oh, I see. It's because so we're defining this in the wrong place. Let's actually do. Let's define it here, but define it as an inline function. Yeah, that's better. And fix that using the definition in debug info. I guess we can move it there. That's a very high priority thing, right? And it's just the definition. Usage elsewhere. Okay, let's see that. Let's see how that goes. Okay. So I made this inline because we are going to call this function a lot. Ooh. I don't know if that's a good idea. Now that I think about it. Jesus. I can define the signature here. This isn't a good idea. Don't do this. Stop. Ah! This is not a good idea. We should go back. Right? Come to debug info. I had to think about it for 1 second to realize that's a terrible idea. Move this to debug info implementation here. Yes, kill that. Yeah, that would have been terrible. Okay. Okay. Include IO stream here. Recompile. Let's see what happens now. I don't think we should get a link error anymore because we moved it down. Because base is linked after all of the other things are done. So by moving it down one level, we should work around the link error. But let's see what happens. I might be wrong. And this is why we don't do everything at once, right? We test a small subset. If it works on that, well, in this case only on the variable value. If it works on that, we'll move the same code everywhere else. If it didn't work on that, well, let me know something is wrong, and then we can go back and change things until it works, right? But if you move all of the files at once, then there's no going back. Linking, executable, damn it. In what order are we linking these? Maybe if I change that. Yeah, parser is before base, so that's not anything. You know what? Why don't I bring it inside here? Okay. And also, you don't need it to be in the base because, say for example, parser doesn't need to invoke this, right? Only AST does. You're going to invoke that only during syntax generation. So maybe this is a better idea. I don't know where to put the error reporting. Okay. Hopefully that's better. Like, in my mind, you have to have that available on every different library that you're using. There's no place that you don't want to just exit, right? You have to have it everywhere, but that's not really true. You only need it in a subset of your program. I think AST is that subset, so we don't use it in parser. We never exit in parser, right? Worst thing that can happen in a parser is returning an empty parser result. That's the worst possible thing. But we shall see. Right. We shall see. So how's everyone doing? Is everything alright with you guys? Did you start your weekend or going to work? Okay, the moment of truth. Does it work? Oh, come on. Seriously? Wow. Why? I don't understand. Don't we use AST like everywhere? We do, don't we? And this is for sure being compiled. Do I need to... No, that got compiled recently. Undefined reference to graceful exit. Huh. What's your problem? They save it? So I know the order matters, the order of the files matters, but I don't think that's the case here. Like, you're only using a glove and they're all in the same place. Maybe if I add ast.cpp first, will that make any difference? No, it doesn't. And that would have been nonsense if it. Oh, actually. Uh, I could go here if that's the case, but I don't think that's going to be the case, right? Where did I go? Okay, yeah, that's not the case. Okay. Right. So we have to place it somewhere else, I think. But I don't know where to put that. Wait, is it the same thing? Let me make sure I spell that correctly. Yeah. Oh. You can yell at me. You have the option to yell at me at this point. Who the fuck forgets that? Like, seriously, who? The signature were different all along. It would have worked in the first place if I fixed the signature. Right. Couldn't find variable undef at that location. That's what I expected to hear. And the good thing is, so if I run it, let's say, if I go here and if I run it here, oh no, I have to open a shell. So if you do something like that, potentially this should be, ah, you should be able to open that file. You know, I don't know, but yeah. So there you go. That's the base of the error reporting, and now we have to go to our grep and replace all of these instances. So instead of writing something like that, we have to say graceful exit. What's the debug? Well, it is get dpg. What's the error? There we go. Primitive type. So graceful exit D not supporting this type in primitive types. I don't even know if that's a graceful thing or not, but have it there. Two. Right. Next, we don't have a debug statement there. Of course not. So where are we calling is sign? Can I pass this instead? Let's leave that one be for now. Okay. Graceful exit, PVG, not supported for floating points. Right. And here, graceful exit, PVG, incomplete implementation for Open primitive. Right. I mean, that shouldn't be an error, but you know, fine. Right. Now, this is actually a good error. We are going to keep this one. Calling cast on non-integer types for address. Graceful exit, PVG, and then I'm going to do that, and that, and that. There you go. And access. We are going to say graceful exit PVG. Let's capture that. Oops. There we go. Interface. Graceful exit PVG. So what's the method? Couldn't find method. On interface. Right. Directive. Now we have a lot of errors inside directive, so we have to be careful. Okay. Graceful exit, DVG, directive, ID not implemented. Okay. Graceful exit, DVG, compile works only on functions. Okay. Graceful exit dbg compile directive doesn't have a correct signature. There you go. Graceful. Well, we don't need, that's not a graceful exit actually for the first time. But that doesn't mean we don't have a debug information to share, right? Now this isn't a graceful exit because we are returning the value returned by the directive. So that's not a graceful exit. However, we still have the debug information to share. Right. What we want to say here is graceful exit dbg assign Okay, shoot, how many are left? 73. Ooh, no, 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 no. Search for lowercase exit. How do I make it? I want to have a space before exit. Right, we have 42 left. Okay. We couldn't do anything about those. Right. Graceful exit debug exit. What? Accessing pointer value of a non-pointer expression. There you go. Binary operator. Graceful exit dbg type doesn't support operator op. Calling aloka on unsupported type. So this aloka gen that you see frequently here, that is when you want to assign, you want this expression to be the receiving end of an assign. So here we are saying something like a plus b equals some value, and this isn't supported. That is why we are returning the error, right? Okay. Cast. Right. So we should gracefully exit here, saying explicitly casting incompatible types. Hello, C Films. Great. How are you doing today? Is everything all right? Calling aloka on unsupported type. We are doing error reporting today. Almost done with it. Only 37 more functions to change, and then we are done. So, graceful exits dbg say struct name is not a type. graceful exit DVG says struct name is not a struct type. Okay? Wait, that doesn't make any sense. Oh, well, okay, that's fine. Graceful exit calling alloca on unsupported type. There you go. Graceful exit and call method on non-struct. Right, and also if you can't find the you did find the struct but you can't find the method, you have to report it as well. So I'm going to say can't find method, whatever the method name is, which is this one, in interface ID. You probably have the same thing going on for structs as well. Yeah. Can't find method in a struct, like so. What are we missing? We are missing a plus sign there. Right, function call. Graceful exit DVG couldn't find function ID. Graceful exit calling alloca on unsupported type. Of course. Now string. Graceful exit DVG calling alloca on unsupported types. The hardest feature to implement probably compiler directives or interfaces. Interfaces. That's the hardest thing. Oops. Yeah, because you have to do so many different things when you want to implement interfaces. I guess that would have been the hardest thing that we have implemented. We don't have a debug statement there. That's the first time. Right. Now what we're going to do here, we are going to, since we are a parse rule, how do you want to handle that? You don't have a location information here, so let's add a to-do statement. What's the problem here? Okay, we can come back to that. Right, return parser. Expected expression didn't convert to expression. Okay. Wow. Don't do that. That's fine. You don't need to worry about that. Okay. Unknown OP in precedence. Oh, that's bad too. Okay, we're going to leave that as well. So this is the territory that I'm not sure how to handle, right? Okay, this we can handle. Graceful exits. The statement we can get from T that gets EDG and say the statement token was not a real statement. We can do that here. Print info and exit on arc parse error. Okay, let's do that later. The exit callback. That's fine. This is fine. Ooh. Yeah, we should have a. Well, we don't have any information here, so we can't properly return the error. We do have the information here, though. That's fine. That is fine too. That is fine too. Now, this isn't fine. Couldn't parse. Yeah. So we want to change that one to. What are the easy features to implement in Rumi? Probably the easiest one would be to implement operators. I think that would be one of the most useful features. That is also the easiest one. So I'm going to say couldn't parse, and then wait. Couldn't parse. We have T, which is a parse result, right? So we can say debug info T. Right? We should be able to say that. Load debug info. Yeah. Right, and we want to graceful exit here. So let's say debug info from T, and then you should say couldn't parse file. Let's say new debug info. What is T? Why can't you parse it? T is defined here and should be accessible there. No? Okay, let's compile it and see what errors we get. No, calculators are the easiest things to implement. There aren't anything hard going on in calculators, so you don't need to worry about them at all. Right. No return is having a function, so we can add a return statement. Well, we are doing a graceful exit, right? So fine. Same error here. I'm guessing we had the same error for every one of the unsupported alloca type, right? Yeah. Fast. Constant integer. Right. Oh, we need to have a debug statement here. Initializing. Okay, that's fine. I fixed that one. Dynamic parse rule. What's your problem? Invalidity of incomplete. Okay, you have to know what's inside of it, don't you? Here it is. It's in debug info.h. That's your file. If that was the same error, constant boolean. Here you go. Function call. There you go. Interface. Or return 0. Rumi has primitive types. We have pointer types. Primitive type, pointer type, structs, interfaces, named type, which is only an alias, and that's it. Primitive types have a lot of different things. You can see the full list here. Right, you still have the no return warning. I'm going to solve that. Oh, come on. Right, return 0. Okay, recompile. Why is Rumi spelled like that? Have to fix that. Right. Missing method parse. There. That fixed now? Yeah. Right. Okay, you're compiling everything. Apparently without an error this time. Okay, so that's good. Let's hope we don't get any warning either. But we are essentially recompiling everything because we changed cc.h. That file is used in all of our C++ files. So when you change that, everything is going to get recompiled. Right. Oh, we do have errors. Where is the error? Ah, okay, do that. Compile and linked. Come on. Almost there. Right. So the compiler finished compiling. And I'm just going to try to make a few errors. So we did try the undef error and we saw the result here. If I do it like that, the compiler says couldn't find variable undef at that file. Now, let's define t as a struct, initialize it. So notice how t doesn't have id. This is another error. Expression doesn't have member id at whatever that is. That's great. That's what we want to see. Thank you, C Films. We've done most of it on stream here too. You can actually try it. Alright, so I want to change the error message to, instead of showing the expression, show the type. So this would be mem access, I believe. Right. So I want to say expression. So what's the expression? Expression of type yeah. I want to say something along those lines. That would be a better error message, so we see that what a struct is actually missing the member, right? Instead of just getting a random message. So if I run that, expression of type t doesn't have member id at that file. That is great. So I'm just gonna, let's go here and remove that. Let's create an interface. So we are saying we have an interface. Is that how we define interfaces? I think that's the first. That's the thing, right? The first feature of Rumi that we developed, I think that was functions. You can look at the git commits and go to git commits and see what was the first one. If you open this link and you go into the commits, see, and if you go back and back, you can probably find it here that the first thing we added was functions. Yeah, base function parser. That was the first thing that we added on December 27th. So it's actually been more than a month that we've been working on this officially. Okay. Right, so I want to do that, and I want to create t as a struct, and I want to create I as that, and assign it to t. Now this should produce an error. Cannot cast types at this file. Okay. It would have been better if you actually wrote y. So let's go there. So you want to go to interface, inside cast, yep, here. I want to go there. So I want to say something along these lines. Struct is missing. Oh, this wouldn't be appropriate here. We have to go there. Is missing, let's say, method. Right. Why don't we have CC here? So now we should get a proper error message when we are casting incompatible struct to interfaces. Ooh, I forgot to add this. Right. Okay. Let's wait for this to finish, and then we can try it. Okay. Run. Struct T is missing method print for interface. That would be better if I add an interface here. Interface. Okay. So that's another acceptable error. I like that. Let's go back. I think that's enough for for one commit. Okay. All right. It wasn't renamed. What are you giving that error? Push. Okay. Now, I think that's fine. That's everything we want to do for now. I'm going to take a short break, and then we can come back and implement something new. See you in a short few minutes. Right. We did the error reporting. I'm happy with what we have at the moment. We can certainly do more, but that's enough for now. Let's focus on something completely new. I think we can start implementing enums. That would be a very good addition to what we have. Um, we can also think about doing other things, but let's start with enum, right? So as always, I'm going to start by creating a test file. So let's create a test 10 and import test import. Now, enums are very basic things. So what we usually have in enums is something like this. So we have an enum defined in this way, and you have different values. So value 1 could be like that, or value 2 could be some other structure. Could be anyway, right? And we want to implement those. Trying to think if let me just double check. Suddenly, I'm not sure if we have used equal sign. Yeah, we have. Okay, but we have comma there, like so. Right. So we want to write the parser for those. That's the first step. The second step would be to do something like this. E would be, you know what? Let's change that to uppercase E. Then we can say something along these lines. E is E, assign E to V2, and then if E equals V2, print correct. So that's what we want to do. That's a very basic approach. That's a very basic, uh, thing that we want to implement. Right, and I'm going to comment these out for now. We can uncomment them as we go forward. But the first thing to do, we should actually be able to parse this, because if I try to parse that now, test test 10. Wow, we even get a seg fault. Why? Do we get the same thing for this one? No, that works, right? So why did we get a seg fault for test 10? This is an empty one. That is very weird. Divide info from token. Ah. Huh. So the token return is not empty. That's bizarre. That is really weird. First line AD, that is this one. Huh. How should we handle this? I have no idea how to handle this one. Maybe maybe we can do this. So we have the source, we have the CC, we have the source, and we have the position. Source is this. Let's do this. This is more important than actually doing anything else, to be honest. Yeah, we have to properly instantiate our debug info. So what we're going to do is this one. Okay, we compile. That's very serious. Because if you have a problem at the top level, Rumi is not going to be able to handle it at this point. But this should solve it, right? I think so. Yeah. This should solve this. So now, yeah, couldn't parse file at line 10. Line 1. Huh. Test 10. I guess that's fine. That is fine, but we should be able to make it better, right? Yeah, we should add the +1 there. Yeah. Because that is on the first line, but if we add the +1, it's going to go to the beginning of the next line. No? What if I do skip write the space and comments on list.str? Right, let's see. This should do it now. Okay. Yeah, couldn't parse file at line 3. Okay, that's fine. Line 3 is the problematic because we don't have a parser for enums yet. Okay. Now let's actually commit this one. Fix up. Push it. Sure. Right. Now, I am going to first do this. I'm going to go to my Emacs configuration for Rumi, and I am going to add enum to the list of keywords. Okay. And if I do Rumi mode again, yeah, okay. I didn't like how that was grayed out like the normal things. Right. So now that the most important thing is done, we can start working on the parser. So like before, we are going to create an enum parser header, and let's cheat and copy things from struct parser. But I don't know how to. Well, I do know how to write a parser, but I don't have it off the top of my mind, right? So we have a symbol. We don't want to define parsers. Ooh, actually, you know what? Maybe we do. The struct parser.c++. So how do you do your thing? How do you parse yourself? So you start by creating a struct token. You parse the ID first, then you look for the column, and then what's that one? Keyword parser. That's the struct keyword. Okay, I see. So no, we don't need define parsers. Okay, let's call this enum token. We have members which are what are our members? Let's call them enum members. Class enum members have a public city string key and an int number which is something, plus a boolean has number, which is false by default. Right. So you have that. We have an ID and then enum token like that. There should be there. This is a C++ file. Please color it like that. Now this is an enum parser. We have our thing like that. We need a ID parser. We don't need a define parser. Keyword parser should be E because we want to look for the enum keyword. And that's it. That's everything, right? We have a column, left curly parenthesis, right curly parenthesis, and we need a comma here. I think that's everything that we need. Right. Thank you, C Films. Now, the C++ parser. So we want to include enum parser like that. Where do we begin? Do we begin with the actual parser? You know what? We should probably do this some other time because let's stop here. We can either continue later today or tomorrow or some other time. That's a weird question to ask. I'm developing Rumi because I want to use the feature I have here. I don't really care about game development that much. This is for me. Others can do whatever they want. This language was designed with me in mind, so I'm putting everything that I need in the language. Yep. I'm getting a little bit tired about and I don't know if I should stop or not. To be honest, it's been how long has it been? It's been 2 hours, I think, right? 2 hours and 9 minutes. Yeah. I'm going to stop now if you guys don't have anything to say, and we can continue either this afternoon or tomorrow morning, depending on how my schedule goes. Yeah, we don't use BNF, eBNF, ERCC, or no. We are actually using recursive parsers because we expect special properties from our language. If you use any of those, you won't be able to do something like this. I won't be able to define a parser in the compile time like I'm doing here. Right? This would be impossible if we take that approach. we use recursive parsers. This is the style that we are using it. So we have a smaller parse parts that we can pipe together to form bigger parsers, and then we can extract our values and create the token and ASD based on that. For example, this is an ID parser piped into a symbol parser, piped into a keyword parser, load it, parsed into a piped into a left curly bracket parser, and then we use a define parser after that, and then we use a right curly bracket parser. So we don't use BNF, eDNF, or ESCC to generate this. We do it our own way. This is it in C++, and this is it in Rumi. So we have the ID parser. Rumi is compiled. Rumi is compiled to bytecode. The compile directive that runs in compile time, that is also compiled and then loaded dynamically. Recompile to LLVMIR. And these statements here, the add compiler statement that run during compile time, they are actually compiled to bytecode and then loaded and then run. You don't interpret anything. But we do expose the compiler API so that the program can change things from inside. Right? For example, the program can add a new parser or set a compiler flag during compile time. Yeah. I think that's the best. Like, this is the best way we could have done it. If we want to do any other way to handle macros, then we had to have a different micro language, right? But this way, you actually write Rumi in order to write macros, which is pretty interesting if you ask me. Right. So let me ask. Let me create a poll actually. New poll. Please participate in the poll if you see it. I want to know what I should do now, because I'm a little bit tired at the moment, to be honest. But I also want to keep working on this. Do you even see it? Like, does it pop up on your screen? Okay, so with that said, let's wait for the vote results. Okay, thank you. Sure. So we can keep going, I guess. Let's work on the enums again. Right. So for the enum, we have to start with the enum parser and initialize it properly. So enum parser, enum parser. So we want to initialize the ID parser, no, the keyword parser to parse enum keyword. So you want to initialize the colon parser to parse symbol colon symbols.h, also keywords.h. Okay. And this is the comma, so symbol comma, left curly bracket, symbol left bracket, and right. Right. Okay. And then we have that. So we don't have the enum keyword defined. So let's do that. Keyword. We have k enum. And in keyword parser, we have to define it. I'm going to define it next to struct. Okay, so we have it defined now, and the parser can recognize it. That was very easy. So next thing, we have to start and actually write the scheme. So how is it going to work? Well, we expect to see a parse result, and the scheme takes a compile context, a source, and a position, and we want to write it. So let's assume that we have a enum token t, new enum token. We have to pass our compile context, our source, and positions. We are going to update the position later on. Now, the first part is the ID, so we expect to see the ID here. And if we didn't see any ID, let's just return the error. Now, this is our ID. Okay, so there we have it. After our ID, we expect to see a colon followed by the enum keyword, followed by left curly brackets. And then we expect to see something else. So what do we expect to see? We expect to see enum items. Right? I'm going to do that. No, I don't like that. I don't like that at all. So we expect to see a base followed by an ID parser. And if there was a thing, let's see if there is a if it's followed by an equal parser, followed by a number. Oh, we have to add those two. And if so, we are going to update it. Okay, so we need to have an equal parser, which small eq, and the number parser. Let's add those. There we go. Right, so we do that. Next, we have so we have to extract it. Let's like to do extract member, and then base to be m. Then try it once more. So we expect to see a comma, followed by another ID parser. And if you do see that, repeat the loop. In the end, if there was such a thing as a comma after the base, because at the end we have an optional comma at the end, do that, right? Then we expect to have a right curly bracket if there was no ends, delete the et and return it. Otherwise, update your thingy. Okay, I think that's okay. Yeah. So, how do we extract the member? Guys, feel free to ask any question you have in chat, or if you want to see anything, do let me know. I'd be happy to show it to you guys. I expect to see an ID token from the tuple token star that is temp.token e2 id. Okay, that's the member name. And if we have a value, ooh, you know what? Let's create an enum member here. Right. And you can say em dash key is this one. Enum member, that's correct. Ah, this is incorrect. So you have your ID, and you say we know that if you do come here, your value would be true. You have a number, and your number would be number token star mean token star temp.token e2 and then value. So you have your member, add it to your list. So et members dot pushback em. Right. When you want to delete, just loop over that. I think we should do the same thing here too. Yeah. Okay. So we do extract our member, we see the comma at the end. And that's it, right? We do everything here. Am I missing anything? I don't think so, right? That is everything. Yeah, that should be everything, right? So let's write the enum token, the constructor for that. So we have if you parameters that we are just going to assign to ourselves. Right. So we assign the values to ourselves, and that is it, right? Yeah. So let's comment out the AST for now. And I'm going to write the description, which is going to be something like this. So we are returning an enum ID with values cd string vals, be an empty string, and for auto em in members vals plus equal /n, something like that. en.key, and if en had a number, vals should have the number here as well. Right, let's compile that. Right. So now the compiler should be able to parse this for us. Can't. Of course. What do you think is going wrong? So, you reach here. Oh, you know why? Because we haven't registered it yet. We have to register all of our things, remember? Yeah. Yeah, we have to remake the CMake, like so, and recompile. Now it is compiled and it is registered. Okay. I think we have to do -v, be able to see it. Come on. Okay. So, what did you parse? Where are you? Where all that? Okay. So we have, these are the code, right? F open exit. Wait. Where is the code for enum? Did I not give you enough verbosity? Alright, here. That's the wrong file. Here. Right. So enum E has v1 equal nothing, v2, v3 equal enum. Okay, that's very weird. You have to fix that. But at least it was able to parse it, which is good. So the numbers aren't being parsed correctly, I think. V3 enum, that's even weirder. So the name is correct. The first the members are correct too, but what's this one? Oh, it's treating this as a string, as a number. Um, what is the method called to convert things to strings? I think it's std to string, right? Yeah. Okay. Fill it now. Okay, run that. And we should be able to see. Okay. So enum e, value 1 has the number 1, value 2 doesn't have any member, doesn't have any default value, value 3 has number 4. Great. Great. So the parsing is complete. Now we have to do the actual generation. And to do that, how do you want to do that? AST star enum token to AST CCCC, like so. So we want to be able to create an enum. So enum star e would be new enum. That's the first thing. And let's set the ID to our ID, and let's set for auto and let's do that, and then return e. Right. So it doesn't know what enum is. That is because we haven't defined enum, to be honest, but we're going to use it anyway for now. And then we are going to come back and actually, we know the signature of the enum that we are going to create, right? It's going to be something like that. Now, enum is going to be a type, so should it be a type? Yeah, it should be. Enum.header. Include a struct.header for inspiration. That's even better. Okay. So I don't think we are going to use that or that. But we are going to include a parser, enum parser, because we want access to the enum member. Okay, so we have an ID. Sure. We have a map, a string to enum members called members. We don't have a generated type. We don't have a constructor. We have an add. What should be called? Add. Where is it? Add member. You do get CC. Okay, that's a good idea. You do get CC and you get a enum member as well. Don't have these inside. Let's make it C++. Oh. Okay. Okay. You don't have those. You have a string. You have a type gen. Compile has op gen. Blah 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 blah. You have all of those. And that's it, right? You don't have reset body, you don't have find name index, but you do need everything else there. Okay, is that good enough for you or not? Oh, I have to change the name to Enum. Is that good enough? Yes, it has to be, right? That's perfect. Okay, so now, wow. We want to say something along these lines, so we have to write the implementation for that. And I don't know how hard the implementation is going to be, but I'm guessing it's not going to be that hard. We can start and we can complain whenever there was something that we couldn't deal with, right? Okay, so we have our add member. Hmm? And I'm going to say members of m.id would be n. And to do name clash, to do value clash. You have to check those. You don't have an ID. What do you have? You have a key, don't you? Yeah. Okay. That's the first thing. That's how we register members in this part. Now, std string enum to string. I'm going to just return. Just going to return my ID. Right? We can even do something like that. Okay. Type generation. Oh no, it's void. Void star enum type gen cc. So we don't have a type generation per se, but we do have is an inner type star inner type that we initialize in our constructor. So enum. Our inner type is a primitive type of type. What's it called? Signed 64. Let's add that. Yeah. So we do everything through our inner type. How do we generate the type? Well, return inner type gen cc. That's how. Right. How do we compile? We have to register ourselves and then compile our inner type. Oh, that's a void. How do we prepare ourselves? I don't think we need to do anything. I don't think our inner type needs to do anything, but I'm just going to call it just in case. Because we never know, right? There might be something that we need to handle there. So that's our prepare. Okay. Do we have an operator? I don't think we have any operators ourselves. Our members do. We do not. So, do we have an operator? No. Bool enum has op. Are you able to complete for me? Do you have an operator? No, I don't. Okay. Void star enum opgen. Can you generate this operator for me? I cannot. Void star enum op Type result. Can you tell me what type this is? No. Okay. Right. Did I write that correctly? Yeah. Okay. So compatibility. How compatible are we? Well, I don't know. Ask my inner type. And the reason why we are using an inner type and we aren't just hard coding everything with a integer is that in future we might want to have enums of a special kind, right? So we're doing that. What's the error there? What is your error? Oh, it's a type. Okay. Can you cast gen for me? I don't know. Ask my unit type. Actually, maybe we should ask the inner type for this one as well. Yeah, let's do that. Just so we have the same thing going everywhere. Okay. What's your problem? Okay, that's cast generation. You have to do all of the rest too. So the has member is actually different. We have to handle that ourselves, right? Oh no, 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 no. No, we shouldn't handle it ourselves. We should do something completely different. Okay, I know what to do. I do know what to do. So, enum has mem. Let's just ask everything from our enum has mem. We ask everything from our inner type for now, right? And type resolve. Oh, is that okay? Yes. Mem aloka. Mem aloka is void star. Okay. And Boolean enum has POP. So we direct everything to our inner type again, two more times. That's POP type resolve. And one last time. Okay, so we basically, well, whatever someone's asking us, we say, I don't know, ask my inner side. That's all we are doing at the moment, right? But, but, there's something else we need to do. And that something else is, so this is an enum instance, right? This is an enum instance. We also need to have an enum, we should something like a class or something else. I don't know how to handle that properly. Okay, I know what to do. Okay, so here we have to register. First, let's do the registration. And for that, I'm going to look at the struct CPP. Right. So you do that. You do this. So we have a new name. The ID is ourself. The type is this. The alloca is 0. Is type is true. What's your problem? You need to know the basics, don't you? There you go. So that's how the enum works. Now, the only other thing we have to change in member, in mem access. So when we want to do the access on things, we need to know if the base type is an enum or not, right? And if it's an enum, we have to do it differently, right? So I'm going to open mem access, that header, and here we're going to say, is it a enum, right? So where should it be? Mem access. When you create yourself, no, when you compile yourself, right? Or is it prepare? I don't know. When you compile yourself, don't just rush there. Are we an enum? So we need to find out whether we are an enum or not. And to do that, we are going to say cc resolve name something lookup. Yeah. So lookup exp. Oh. Lookup. Okay. So first of all, a few one step back. If my expression is a variable value star v from a dynamic cast, so if our base expression is a variable value, there is a chance that we are an enum. And how do we make sure we are one? Well, we do something like this. We get the named registration and we check to see if it's an enum or not. So is it an enum? We want to cast and type, I believe. Yes. Before that, make sure it's in type. Otherwise, you're just going to cause troubles for yourself. And so this would be pretty similar if you wanted to actually to take similar approach for a static members of a struct. So if we have a static members in future, this is similar to what we need to do. Right. So what's your problem? This should be a pointer. Okay, so at this point, we know we are an enum. And we want to know if we are we want to know we don't need to do any more compilation, but make sure the member exists. So if e dot members dot find my ID was equal to e dot members dot end exits. Oh, it's graceful exits. UG enum e ID doesn't have member ID. Okay? So we make sure the member exists. If not, we return the error. Awesome. So that is solved. And we have the return statement so we don't do the rest. Okay? Actually, we do need to do the rest. So, and also this should be typed at base type. Yeah. Okay, that's fine. We leave the to do there for static members. Now, if you're asking about our type, if you're asking about our lookup, if I am a Boolean, the answer is no. You're asking about my type, the answer is, oh, so you know what? What am I doing there? Instead of doing that, I'm gonna say enum star e, which is by default 0. And instead of saying enum is true, I'm gonna say list.e is equal to e, right? Now here, you want member access. You want to assign something to me. If I am a enum, I want to say no. Okay. Let's just add a class enum there so that we don't get any errors. Right. Yeah. You want to know my type. If I am an enum, you can get my inner type. Yes. That is exactly correct. You want me to generate something for you? Well, if I am an enum, why did I do that? If I am an enum, your answer would be a constant integer, or you know what? Let's say e dot enum mem gen cc and id. So we will add that to the enum class. Void star enum member generator cc star cc and std string ib. Just that's the least we can do, right? Okay. That's everything. That is absolutely everything. We just have to write that method, which you can do. It's not hard. It's not hard at all. And city string ID. Right. So all you have to do is return Let's first include LLVM. So we have a constant integer. I don't know how to. I'm gonna cheat. Yeah. Except I'm not gonna write the type myself. I'm gonna rely on my inner type to do the type gen. And the value would be this one, members of ID dot number. So all we have to do now is to make sure we have the correct number here in the compile. How do we do that? Well, we start by having a counter. Yeah, and we get that from members. Okay, we have a counter that starts at 0. However, if members wait, that's not gonna work. That's not gonna work. We also need a see. We need a vector of the members too. We need to have the members in order. The vector of inner members mem array. Let's call it that. And when you add a member, oh, I don't need to do it there. I don't need that. All I need is to have a counter which is last, and which is a boolean which is initial. Right. So here, if I was not initiated, I don't know how to write that. Is that correct? Yeah, that's correct. Okay. So if I was not initiated, I have to assign last. And to do so, I'm going to look at whether this has a number or not. If it has a number, my last would be this number minus 1. Else, my last would be 0. Okay. And then initiated would be true. Now, we do assign that. So we assign that. That's fine. Now we do have a last. So if m has so this is general. If you have a number, we have to make sure that it's bigger than the last one. So if last is less than or equal to your number, we have to exit gracefully. student enum member has a value greater than the less than the previous one dash 10. Maybe change their order. Okay, and I can add the member name. That would be m.key and that. Okay, so we have a graceful exit there. Otherwise, we can bump last to be m.number -1, and now we can increment last and assign it to no. This case last would be that. Okay, so if you don't have a number, I'm going to increase last and assign that to you. So that's how we assign the value. That's value clash. Now name clash. So name clash would be something like this. If members dot find and dot key didn't equal to members dot end, graceful exit debug enum has repeated definition for member and key. That's it. That's it, folks. That's enums for you. To generate CMake, compile, hopefully without any errors. That was a lot. We changed a lot. It took us exactly 50 minutes to implement that. Or if it works, There's a very real possibility that it's not going to work. Enum memgen, undefined reference. Wait, what? Enum memgen, that's correct, right? Yeah. Maybe a typo somewhere. Oh. Undefined reference to that. Who is calling that? Ooh, I know. Accesses. Okay, I think maybe we actually have another problem then. Oh yeah, we have to do that too. Okay. Void star enum memgen then, like all good functions, call your inner type. Okay. I think that should be it. Yeah. At least we didn't get a compiler error. That's good. Now, let's try it out. So why did you get a seg fault if you had a graceful exit? Oh, you didn't have a debug statement, correct? And by the way, we won in test 10 actually. Yeah. That's one. How the hell is that less than the previous one? Oh, this is in reverse. Right. Okay, I see the problem. But that doesn't explain why we got that error. Oh, debug info wasn't what? How could... Oh! You have 2 ASD. You shouldn't have 2 ASD. Should you? I don't know. Let's look at a strong parser. You have 2 ASD? Yeah, you do. Wait. So you're telling me this function doesn't have a debug statement? Is that it? That is very weird because we actually do assign everything. Right. So what I'm going to do now, I'm going to come to test 10. Let's define it. Let's actually do everything. We should be able to do everything. I did code everything. Right, so this should be e.v2, and this should be e.v2 as well. And run it. Correct! Yay! So that actually worked. Enums actually work. Let's see what the error is though. So if I add a new value with something less than the previous one, why? Okay. Let's repeat the value. Yeah, you shouldn't do a seg fault. You honestly shouldn't do a seg fault. Shoot. Oh, I know why. Oh god, I know. I know why. Because this method is being called inside the parser. Right? Yeah, this method is being called before TUASD is finished. That is why you're getting that error. So I have to say something like set dbg to my debug statement. That's embarrassing. But that's fine. It happens to everyone. Right. Enum number v5 has a value less than the previous one. Maybe change the order at that place. That's great. So if I, well, now let's see if I add a new value with the name clash. Enum has a bit definition for number v1 at that line. That's great. Perfect. So let's actually see the value though. Correct with value percent %d. What's the value of e? It should be a number, right? Correct with value 2. But if I change that to v3, is it 4? So there you go. That's enums. Now we have to expose the enums API to our compile time library. How do we do that? Well, I mean, I know how do we do that. I want to take a break. I'll be back in a few minutes. Okay, so let's continue with exposing our API. We should, so we have two things to expose, a parser and an AST. Let's start with the parser. Now, I don't know what's closest to enums alphabetically. I think it will be define. Let's see. Do we have anything A, B, C, D? Expression. Okay. So expression parser, yeah. We have an enum parser here. It's a struct. We have an enum expression parser parse result. That's also a struct. Now, this one has a getID method. It also has a getMember method that takes an integer and takes back getMember key and getMember value. I'm gonna return a pointer to an integer. No. Yeah, just an integer. And a as member value. This one returns a boolean. Okay, so that's all of our getters for the parse result. Now, we actually should do a compiler that gets enum parser. Like so, and to parse and parse after. Okay, so I'm just going to copy them from there. This should be enum parser.parse, parse after, parse results. Right. Why are they all expression parsers? They should be enum parsers. Right. Right. So we have to expose those functions. Let's go directive parser. Include parser enum parser.header. So just go through them one by one, right? When you want an enum parser, you get an enum parser. When you want to let's copy those lines. We're going to reuse them. Right. So enum parser and enum parser. enum parser. That's okay. That's all of our parsers. Now, the parse results thingies, we have to do them one by one as well. So we do a char star. Surprisingly, all of them return, you know, values. They don't return tokens. That is good. That is easier to do, I guess. So it's cp underline enum parser parse results gets id, and you have a parse result a star p. Okay, so first of all, if there was no p, return 0. Second, your token would be enum token star from p dash token. Now, you want to be able to, you want to say return str to cstr t dot id. Okay. Yep, that's correct. Now, same thing for the other one. So member key, member value, member has value. Okay. Result gets member key, and you also have an ID this time. First of all, if I was more than members that size, return 0. That's correct. Now we want to return str to cstr t dot members I and then t. Right. Next we have int get member value, and we won't do that anymore. We just say sum. And the next one will be has member value, the boolean, that's a get, that is also a get. Okay, so this one would be, instead of num, we'll say mon as num. Right, so we wrote those. Let's go to directive parser and register them here. So how do we register those? We just copy them here, copy them here. Right, because this is taking a lot of time, I'm gonna go to text mode, so this is easier to process. Record a macro, jump to that, delete that, yank that 3 times. So this would be a dollar, this would be a dollar underline replace added to the end, and this would be capitalized. Now we say register callback, open parentheses, you add that there, like so, like so, like so, like so, like so, add a semicolon, that, and that. You go down, you go to the beginning, you stop your macro. Do that once more, once more, once more, once more. 2 more times. Right. Now we go back to C++ mode and we sort these. Great. Now that's enum parser interface. Now all there is left is the enum AST interface. Okay. I don't really have the energy to do this anymore, but we have to, right? So ast.rum, let's find directive. So this would be a C enum empty struct again. We have compiler that creates enum. Ooh, there's a bug here. This should return a pointer. Good thing we catch that. That would have been a disaster. Right. So we have a get ID and a set ID. So the enum.getID returns a string. C enum.setID as a unit. We have C enum.add member. Now, what do we have? We have a key only. And we have C enum add member value. Like so. Right. Finally, we have C enum gets member key, which takes an integer and returns a string. C enum gets member value, which takes an integer. Oh, we don't have the integer here. Right. We don't have integers there. We have lost all of the values at that point. Oh god. Yeah, we have lost the values. An alternative would be to we should capture the values. There's no way around it. Okay. So member value, you get the actually I want this to work with keys, but the other one to work with strings. And finally, we have enum that counts members. Right. So I really didn't want to do this, but I guess we don't have a choice really. We have to add a std vector of a std string member orders like so, and we should go here. When you add a member, right at the end, member orders dot push add back and dot key. There's no way around that. Honestly, we do have to do that. And we are resolving name classes, so there's no need to do that. Okay, so that's that. Now we just have to implement these 1, 2, 8 methods. That's fine. We go to directive. This is enum. Just want to verify something. Parser. Am I actually using tokens there? Okay, so enum star creates enum. Oh, wait. Okay, that's fine. For some reason, I can't trust myself. I think I've made a mistake somewhere. Okay, so we return a new enum. That's easy. Get ID. The enum gets ID. ID should be lowercase d. Okay, so what should we do here? We get an enum star e at the beginning and return str to cstr of eid. There you go. That was easy. Right. Member key. Char star c enum member key of enum star e and integer I. So verify that's in range. So if I is greater than or equal e dot e members that size return 0, otherwise return member orders that I, and that would be a str to cstr. Okay. Give it a second. There are macros going on in the background, so the errors will be fine. Okay, so that's that. Member value based on a key. So we want to have int c enum member value. Have in mind that at this point we certainly have a value, because if you don't have it yourself, the compiler has assigned one to you, so that's fine. Right. You have a char star c key, and you want to capture that value. So m would be e dot members cstr to str c key. Okay. Should be I think we need to make sure that this exists first of all. So I'm not gonna do that. Instead, I'm going to say find. Okay. And if m was equal to e members dot n, I'm going to return. But I can't do anything, can I? No, I can't do anything here. And that was fine. But here I have to say return this one dot number. If there is an error, you will get an error. This would be c enum member get member key. This would be enum get member value. Now we have a pretty similar thing for boolean, and instead of get we have has member value. Instead of number we have has number. So this tells us whether we have a default number or not. the count members. See enum count members enum star e. We are going to return e member orders. Oh, not that one. Just member orders dot size. Okay, here we have it. I'll take a sip of water because this is very tiresome for me. All right. So we have count members. Now we have to add set ID and add member value. You can certainly do that. Void c enum set ID. You get your enum star e and a char star ID. Set eid cstr to str ID. Dot c enum add member enum star e char star key. You are going to say e dot add member. Oh, we need CC here. Okay. Okay, that's fine. The add member requires you to pass in the compiler. So you have to pass in your compiler. Now, there should be new enum cstr to str key. Okay. And mem dot has number would be false. I think we do that by default, but I'm just going to do it out of, precaution. Right, set member value as an integer value. You set this to true and mem num would be value. There you go. That is all of it. Okay, so let's go to directive. I'm actually going to go there. Oh, wait. Enum should be after directive, not before. I mean, that's fine, but let's be consistent. After directive, before function call. Here as well. I'll go there. Function call, okay. Jump to there. So this would be enum, and you are going to copy those, paste them here, go to text mode. 1, 2, 3, 4, 5, 6, 7, 8, 9. So do the macro 9 times. And then we wait. I found that if I go to text mode and then run a macro, Emacs is going to be a lot faster. Like you see that finished before I finished my sentence. If you were in C++ mode, it would have been a nightmare. Right. This should be everything. Let's compile it. Oh, we have an error. What's your fucking error? The name is different. I know. Enum dot. Yeah, it should be create enum, not compiler create enum. Okay. That's fine. We fix that. We know how to fix that. It's been 4 hours, I think, since we've been working on the problem. Okay, no compilation error. Now, if we can compile test 9, you know that everything is fine. We cannot. Let's see the drum line 84. That's very good that we have that. Oh, right. It should be C compiler, not the other way around. Very good that we have the line number. Otherwise, I was going to go crazy over where the error is. And it actually finished without any errors. So, remove the VG cores. Commit added enums. Those in brackets. There we go. Push. There. Finally. It took me too long to implement that. It took me more than 2 hours, I think. But we have it anyway. So I'm happy about that. We have a very good error reporting system. We have enums in our system. Just out of curiosity, I'm not sure if this is going to work or not, but I want to try something. So if I go to the this is the previous code. I want to see if I can compile it. Line 479. What's there? Oh, character literals. We don't have those in Rumi, so no, we can't parse that. Okay. But anyway, that was fun. Thank you for joining me. We did a lot done today. I really appreciate you guys being here. Hopefully, you can join me tomorrow for some more compiler development. And don't, feel free to approach me, send me any messages if you have any questions, if you want to work on it.